Today we're going to be talking about cloud computing, intranets and extranets, metropolitan area networks, wide area networks, and even security concerns that it's not labeled here, security concerns and other issues that are involved with voice over IP, and an overview of what we talked about today. So when we talk about cloud computing, we're talking about centralized systems, the virtualization of hardware and software. We're taking a user that's able to use shared resources in a cloud or a computing environment where it's very similar to electricity, where we're using electricity as a utility, and we're getting that as a service as we go along. Benefits are reduced costs, more flexibility in IT, scalability, elasticity, and performance. All this means is that we don't have to build 12 servers in order to expand. We can make the changes on the fly. We can adjust for power, space, and memory. And these are all great benefits with little to very little cost in terms of expense. We have the infrastructure as a service, platform as a service, and software as a service. So these are the three types of models that we have. Infrastructure is the bare bones, platform is adding the operating system, and software as a service is adding the apps, the operating system, as well as the backbone. That's basically all in one. Security is very complex to adjust into this model. It's many different parts to secure. There's really no transparency with the vendors. You have to have trust with the vendor that's securing your data and applications. And there's legal issues. Got to make sure that compliance is met with government regulations. Moving on, we have intranets and extranets. Now, an intranet was a private network. It was a way for a company to host a site in order to allow the employees to access the same calendar, the same forms, the same applications, making sure they were on the same page. It would use web servers, client machines, and HTML, XML, HTTP languages on those websites. An extranet was working in the opposite manner. It would have their services hosted on the outside network, or let me say it again. It was working on the outside network, and it would allow for B2B to occur, or business-to-business transactions. They used something called electronic data interchange, which was a standard for sending electronic forms, and this was considered a value-added network. An example of this would be Walmart submitting a form to request supplies from a different company on the outside. A way to get this done would be using a metropolitan area network. This is a technology bridging LANs, WANs, and internet. It was based on a city-by-city basis, anything that was nearby. It would use a SONET, or a synchronous optical network, which was a standard for sending the data like voice, video, and data on fiber optics. And it was self-healing. To cover larger areas, they would use a WAN, or a wide area network. It would again cover a large geographic area, and the principle here was to work in cities that were further away or in a different part of the country if they needed to. Next up is WAN technologies. We're talking about how companies can decide what's best for them in terms of bandwidth, in terms of service, and we have something called a channel service unit, data service unit, or CSU, DSU. That's something that we use in order to make sure that we have a connection between a LAN to a WAN environment. And a good example of that would be your gateway at the house. It's acting like a translator, and it's taking the digital signal and converting it to something that the WAN can use. We also have something called switches. We have circuit switching and packet switching. Circuit switching is a way to set up a virtual connection, and it creates this dedicated link, kind of like telephone calls, where there's some circuit switching involved. When you make the telephone call, you call someone, it actually sets up a permanent or virtual link to make sure that that dedicated communication link is set up and it'll remain that way. In packet switching, it's different. It actually doesn't have a virtual link. It works in the same fashion as the internet and even voice over IP. It's jumping through many hoops, many nodes in order to get that connection or that data transmitted to the other end. Frame relay is using packet switching, and it uses a data link layer. It's allowing customers to use a shared medium so that when they want to communicate, it goes from a point to point. Excuse me, not a point to point, but it goes from like this one pipeline where you have different things going into it using this one shared medium. Frame relay actually uses frames and transmits those frames across virtual circuits. These circuits can be permanent or switched. A permanent virtual circuit is where you have a continuous dedicated private line for a customer where they have agreed upon resources for availability. Whereas virtual circuits, it works just like a telephone call. You make the call and the connection is set up. Once the call is ended, you can go ahead and kill the connection. And then we have ATM. ATM is a cell switching technology using a fixed length or a cell size that allows for good transmission for voice and video. Basically sets up the virtual circuit, acts like a dedicated path for the source and destination devices, and is primarily used by carriers and service providers. Okay, so up next we have the switched multi-megabit data service protocol. It is a high-speed packet switch protocol. It extends LANs to MANs and WANs and is considered connectionless. It is something that is being replaced by other WAN technologies. It is very rare to find now. It's not really being used a whole lot. We have SDLC. SDLC is a synchronous data link control protocol. That is something that we use in networks for dedicated leased lines. But that is also being replaced as well with the HDLC protocol. IBM created this in 1970, but it has evolved into HDLC. HDLC in itself is a high-level data link control protocol, and that's an extension, as I said before, of SDLC. It is still being used, and it is continuing to evolve. PPP, that is point-to-point protocol that is similar to HDLC, except that it acts like an encapsulation protocol. It has several different functions. It has the link control protocol and the network control protocol. Link controls establish, configure, and maintain the connection, where the network it is primarily used for authentication capability or features. HSSI, that actually stands for High Speed Serial Interface, and that's really just to connect multiplexers and routers to very high speed communication systems and devices like ATM and frame relay. Supports up to 52 megabits per second. Up next we have multi-service access technologies. These combine several different types of communication categories. Data, voice, and video are some of them. This is also using public switch telephone networks, or PSTN, which are legacy circuit based. We also have voice over IP. Voice over IP is something that was commonly used with today's internet service providers. It's a session initiation protocol using TCP or UDP. And the idea here is that we're replacing PSTN with voice over IP because it's very limited in additional services. PSTN is inflexible, whereas voice over IP, where you can add many different features because of the technology involved. H.323, well, that's really just a gateway. It's a kind of a guideline or recommendation of a wide variety of different communication services. And it's basically a standard of how we deal with audio, data, and video. And it allows for translation functionality. It also allows for PBXs, or private branch exchanges, to transmit frame relay, ATM, or internet. So the big things we need to make sure is that, as far as voice over IP, is that attackers can sniff those calls. They can steal the passwords and phone numbers. They can commit toll fraud, and they can redirect and masquerade those calls from users that are making the call and redirect them somewhere else. It's also open to DOS attacks because of the nature of the technology. In this case, it's very similar to how we use the internet and how we use the networks with our computers. Okay, so we talked about understanding the WAN technologies such as CSU, DSU, to even using frame relay, H.323. We talked about the evolution of telecom and how we're evolving from different technologies, how we're transitioning from PSTN to voice over IP, or even other WAN technologies, dedicated links, how the telephone call works, but even also how virtual connections work, the future of WAN and how that's also changing and it continues to change. and security concerns that are involved, especially with voice over IP or any internet-based connection or technology. That's basically it.